In 1999, the Mojave Desert served as the isolated staging ground for a high-stakes aerospace experiment. This 63-foot-tall cone is the Roton atmospheric test vehicle, a multi-million-dollar, fully functioning prototype for a commercial spacecraft. Founders Bevon McKini and Gary Hudson established the Rotary Rocket Company to solve a single economic problem. They wanted to cut the cost of launching payloads into low Earth orbit by a factor of 10. At the time, the industry was paralyzed by the expense of disposable rockets and the high maintenance of the space shuttle. McKini and Hudson believed the only way to make space travel routine was a fully reusable, single-stage-to-orbit vehicle, a ship that could launch and land without discarding a single part. The physics of a single-stage spacecraft are incredibly restrictive. Every pound dedicated to traditional landing hardware, like heavy wings, landing gear, or parachutes, is a pound of payload capacity you lose. McKini proposed a radical alternative, replacing those traditional landing systems entirely with a deployable helicopter rotor. At launch, tiny tip jets fire from the rotor blades, pulling the ship through the thick lower atmosphere. As air thins, the spinning rotor shaft becomes a massive turbopump, feeding fuel and oxidizer into the primary rocket engine. However, calculations eventually revealed a physics flaw that the team couldn't overcome. Once the vehicle left the atmosphere, the rotors offered zero lift or pumping advantage. They became thousands of pounds of dead weight that had to be carried all the way to orbit. The engineering challenges coincided with a market crash. The bankruptcy of the Iridium satellite phone network signaled the end of the small satellite boom, forcing Rotary Rocket to redesign their vehicle for much heavier payloads. Their second iteration used a spinning aerospike engine. Centrifugal force pushed fuel to rim thrusters, replacing heavy pumps. During re-entry, the base acted as a water-cooled heat shield, flashing water into steam to deflect heat. Finally, nose rotors deployed for an unpowered, soft landing. This design solved the weight problem by using rotation for almost everything, centrifugal force to move fuel, and auto-rotation to replace the weight of wings or parachutes. In 1999, the team moved to prove the concept by building the atmospheric test vehicle. Because they were operating on a startup budget, they didn't build a bespoke landing system. Instead, they salvaged a rotor head from a crashed Sikorsky helicopter for $50,000 and bolted it to the top of the prototype. Inside, the pilots occupied a space nicknamed the Batcave. With zero outward visibility, they relied entirely on sonar altimeters and digital screens to judge their proximity to the ground. During Hob tests, the rotor wake battered the airframe, creating violent vibrations that shook components loose. The ship was notoriously unstable. The test pilots gave the crafts a 10 on the Cooper-Harper scale, the highest possible rating for difficulty. In the world of flight testing, a 10 means the vehicle is effectively unflyable. The project eventually ran out of money. Venture capital for high-risk space startups evaporated before the company could ever build its complex spinning engine. Rotary Rocket closed its doors in 2001, leaving its prototype to sit as a gate guard at the Mojave spaceport. While the vehicle failed, its engineering team achieved a world first: the successful development of a lightweight, carbon composite liquid oxygen tank. This material breakthrough proved that a small private company could solve manufacturing challenges that had frustrated NASA's own reusable rocket programs. The project's alumni went on to found X-Corp Aerospace, and its co-pilot Brian Benny eventually piloted the first private vehicle into space. By proving a lean startup could build and fly a full-scale orbital prototype, Rotary Rocket provided the technical and human template for the private space industry that followed.